Hello, everyone, and welcome back. I hope you've been practicing everything we've learned so far because today's lesson is one of the biggest milestones in your Python journey. So let's think about everything we've covered up to this point. Our programs can display information using print, store data in variables, accept user input, perform calculations using operators, compare values using comparison operators, and combine conditions using logical operators. That's already a lot of progress, but there's still something missing our programs can do. They can make a decision. Imagine opening a calculator, you press the plus button. The calculator decides to perform addition. If you press the minus button, it decides to subtract. Or imagine logging into your email. If your password is correct, you enter your account. If it's incorrect, you're denied access. Notice something all of these examples have in common. They involve making a decision. Programs constantly need to decide what to do on different situations. Today, we are going to teach Python how to make those decisions. This is where conditional statements comes in. By the end of this lesson, your programs will be able to decide what code to execute depending on the different conditions. This is one of the most important programming concepts you'll ever learn. Let's begin. Before looking at code, let's think about how often we make decisions in everyday life. So imagine with me. So you're leaving your house in the morning. You might think, if it's raining, I'll take an umbrella. Otherwise, I won't. That's a decision. Or perhaps you're hungry. If the restaurant is open, I'll eat there. Otherwise, I'll cook at home. Again, that's a decision. Let's look at another example. Suppose your phone battery reaches 10%. What happens? The phone displays a low battery warning. But if the battery is 80%, it doesn't show that warning. The phone is checking a condition before deciding what to do. Humans make thousands of decisions every day. Programs do exactly the same. The only difference is that computers follow precise instructions. They don't guess and they don't assume. They simply check whether a condition is true or false, then follow the instructions we've written. Before learning conditional statements, let's quickly review something from the previous lesson. If you can remember the Boolean values, that is, a Boolean value can only be one of the two things, true or false, comparison operators always returns one of these values. For example, to print 10 greater than 5 will output true because 10 is greater than 5. These Boolean values are exactly what conditional statements use to make decisions. Think of them as the answers to yes or no questions. So, what exactly is a conditional statement? A conditional statement allows a program to execute a certain code only if a condition is true. Let's imagine a very simple flowchart. As you can see on the slide as well, the decision comes first. The action depends on the answer. Python works the same way. It will first check the said condition, and if that condition is true, it will execute one piece of code. If it is false, it skips that code or executes something different. This is why they are called conditional statements. The simplest conditional statement in Python is called if statement. Its syntax looks like this. If condition, execute the code. Let's examine each part carefully. The word if is a keyword in Python. Keywords are reserved words with special meanings. After that comes a condition. Usually this condition is a comparison. And finally, the colon. The colon tells the Python that the code block is about to begin. Then we indent the next line. This indentation is extremely important. We'll see why in just a moment. So let's write our very first conditional program. Let's understand this code step by step. Here what I've done is I've taken a variable age and assigned it a value that is 20. Then I've written a if statement that is if age is greater than or equal to 20, print the said statement. Since the condition is true, Python will execute the indented line. Now let's change just one thing. Instead of 20, I'll use 15 this time. Let's run the program after making the said changes. Now I'll save the program and let's run it again. And as you can see, nothing happens. Why? Because Python checks the condition. Is 15 greater than or equal to 20? No. So the answer is false. Since the condition is false, Python simply skips the code. This is a very important behavior. An if statement only executes its block when the condition is true. Otherwise, it will ignore it completely. Now let's discuss one of the most important rules in Python. Indentation. Most programming languages use braces to indicate whether a block of code begins and ends. Python doesn't use braces. Instead, Python uses indentation. Look at this example for a moment. Notice that the print statement is pushed slightly to the right. Usually, this indentation is 4 spaces or 1 tab. It tells Python this line belongs to the if statement. Now look on the right hand side and try to run it. Python will give an error. Why? Because it expected an indented block after the colon. The indentation isn't optional. It's part of the Python syntax. One of the reasons Python is considered beginner-friendly language is because indentation makes the programs easier to read rather than using braces like the rest of the programs do. An if statement isn't limited to just one line. It can execute several lines. For example, notice that every line inside the block is indented. When the condition is true, Python executes every indented line, and if the condition is false, it will skip all of them. Let's give this code a try. So I'll just run this code and let's see what the output is. And as you can see, both the lines gets printed. So in the previous section, we learned about the if statement. Our programs can now make simple decisions. They check a condition, and if that condition is true, they execute a block of code. But what happens if the condition is false? Let's think about a previous example. When we ran this code, nothing happened. No message appeared. The program simply skipped the if block and moved on. Sometimes that's perfectly fine. However, in many real-world situations, we want our program to respond in both cases. For example, if you're old enough, allow voting. Otherwise, explain why you cannot vote. Instead of doing nothing, we want our program to perform a different action. This is exactly why Python provides the else statement. The else statement tells Python if the condition above is false, then execute this block of code instead. Think of it like making a choice between the two paths. Imagine you're leaving your house. You ask yourself, if it's raining, I'll take an umbrella. Otherwise, I'll leave it at home. One of those two things will always happen. The same idea applies in programming. An if-else statement always chooses one path and never both. Let's look at the basic structure of an if-else statement. And let's understand each part. First, the Python checks the condition. If it's true, it executes the code inside the if block. Once it's finished, it skips the else block. However, if the condition is false, Python ignores the if block and executes the else block. Only one block runs during each execution. Here's a simple flowchart. Notice that there are only two possible outcomes. Either the condition is true or it is not. This makes if-else perfect whenever there are exactly two possible choices. Let's build our first complete decision-making program, a voting eligibility checker. Notice what we've done here. So first, I defined a variable called age, which will prompt the user to input their age. After that, there are two conditional statements, if and else. We first will check if the age is greater than or equal to 18, and if it is, we will print out you're eligible to vote. else we will simply print out that you're not eligible to vote yet. Let's test the program and let's give it some number, let's say 20. And as you can see, Python checks if 20 is greater than or equal to 18, and the result is true. So Python executes print, you are eligible to vote. So the output comes out to be that I am eligible to vote. Let's test another value. This time let's take 15 as our input, and let's see what is the output. And as you can see, 15 is less than 18, and the result comes out to be false. So the else block gets executed. That is, you are not eligible to vote gets printed. Let's build another practical program. We'll determine whether a number is even or odd. Remember from a previous lesson that the modulus operator gives us the remainder after division. And if a number divided by 2 leaves a remainder of 0, it is even. Otherwise, it is not. So as you can see, I've taken a variable number in which I will ask the user to input a number. After that, I've taken a conditional statement if, in which I check if the number's division with 2 resulted in a 0 remainder. If it is, then we will go ahead and print out that the number is even, else we will simply print out the number is odd. Now, as you can see, there are 2 ways we can solve this program. That is, first, by simply writing number %2 is equal to 0. That is, we are checking if the remainder comes out to be 0. Or we can simply do number %2 not equal to 0 and print out odd instead. Both of those programs works with the same logic, but just some slightly different statements, yet the output will still be the same. Let's test our current program. So I'll just input 5, let's see. And as you can see, it prints out that the number is odd. So Python calculates 5% 2, and the remainder is not 0. So the first condition, that is 0 equal 0, becomes false. So the else statement gets executed. That is, the number is odd gets printed. So far in this lesson, we've learned 2 very important conditional statements. First, we learned the if statement, which allows our program to execute only when a condition is true. Then we learned the if-else statement, which allows our programs to choose between 2 possible outcomes. But what happens when there are more than 2 possibilities? Let's imagine you are a teacher grading an exam. If a student scores 90 or above, they get in grade A. If they score 75 to 89, they get grade B. If they score below 50, they fail. Can we solve this only using if and else? Not very easy. There are simply too many possible outcomes. This is exactly why Python provides another keyword called Elif. Today we are going to learn how to make our programs choose from many different options, not just 2. So let's begin with a simple question. Suppose you're building a weather application. If the temperature is above 35 degrees Celsius, the display is very hot. And if it is above 25, we will display warm. Otherwise, we will simply display cold. There aren't just 2 choices anymore. There are total 3 choices. Similarly, think about a traffic light. A traffic light can be red, yellow, and green. Again, there are more than 2 possibilities. This is where Elif becomes more useful. The word Elif stands for else if. It means that if the previous condition was false, check this new condition. You can have as many Elif statements as you need. Here's the basic structure of the if, Elif, and else structure. It first starts with the if statement. If that condition is true, Python executes the block and stops checking the remaining conditions. If the first condition is false, Python checks the first Elif condition. If that's false too, it will check the next Elif condition. And if none of the conditions are true, Python will simply execute the else block. An important thing to remember is only one block executes. Even if multiple conditions could technically be true, Python stops at the first matching condition. So let's build our first program using Elif. So we will be building a simple student grading system. So as you can see, I've first taken a variable called marks in which will allow the user to input their marks. After which I have 4 conditional statements, that is 1 if and 2 elif statements. In the first, I check that if the marks are greater than or equal to 90, we will print out the grade A. If the marks are greater than or equal to 75, we will print out B. And if the marks are greater than or equal to 50, we will print out C. If all of the above conditions fail, we will simply print out fail. Let's test the program, and now let's input a grade. Let's see, 95. And yes, 95 is greater than or equal to 90, so Python will print grade A. Python does not check any of the elif statements after that. Let's take another example. Instead of 95, what if I just take like 40, and let's give it 40. And as you can see, I didn't pass. So let's understand why the order of the conditions matter. Suppose we accidentally wrote the conditions the opposite way. That is, instead of having marks greater than or equal to 50 at the bottom, we wrote it at the top. What will happen? The first condition asks that if 95 is greater than or equal to 50, which will be true. So the Python will immediately print out grade C, even if the marks 95 are more than 90. So I should get grade A. But since the condition that was greater than 50 was at the top, it will get printed first. And then it will just stop, because it will never check the other conditions, and that's incorrect. A student scoring 95 should receive a grade A. The solution is simple. Always place the most specific or highest condition first. Ordering your conditions correctly is extremely important. So far, we've learned 3 different ways to make decisions in Python. We first started with the if statement, which lets our programs to perform an action only when a condition is true. Then we learned the if-else statement, allowing our programs to choose between 2 different outcomes. Finally, we explored elif, which lets us choose from multiple possibilities. These are powerful tools, but many real-world programs requires more than 1 condition before making a statement. Think about logging into your email account. The program doesn't just check your username, it also checks your password. Both pieces of information must be correct before the access is granted. Or imagine withdrawing money from an ATM. The machine checks, is the PIN correct? Does the account even have enough money to begin with? Only if both of the conditions are true will the ATM dispense cash. Now we learn how to create these kinds of decisions using nested conditional statements and logical operators. So let's begin with the nested conditions. The word nested means something placed inside something else. For example, a smaller box placed inside a larger box. In programming, a nested condition means placing one if statement inside the another if statement. The first if statement is checked, and if it is true, Python enters that block. Inside that block, it can check another condition. This allows us to make decisions in stages. Think of it as asking one question first, and only if the answer is yes, then asking a second question. Here's the general structure. Notice something important, that the second if statement is indented inside the first one. This means that the Python only reaches the second condition if the first condition is already true. If the first condition is false, Python skips everything inside it. Imagine you are entering a restricted event. The rules are that you must be 18 years old and you must also have a valid ID card. So let's write the program. So as you can see, I've taken two variables, that is age and has ID. In the first one, I asked the user to input their age, which I then convert into an integer. The second one, I ask the user to input a specific string, that is yes or no. And then I've taken one nested statement, that is, if the age is greater than or equal to 18, we will go ahead and start with the nested statement, that is, if has ID is also yes. Only then will we print out entry allowed. Let's test the program. So I will go ahead and input 20, and after which I will go ahead and input yes, and I will hit enter. And as you can see, Python first checks if the age is greater than or equal to 18. This is true. So the Python moves inside the first if. Now it checks if the has ID is equal to yes. This is also true. So the output is entry allowed. Let's try another example. Instead of me putting in something greater than 18, let's use something less than 18. So I'll just go ahead and input 16 and ID yes. And the first condition is false, so the Python will never even check whether the user has an ID. It will just skip the entire nested block. Nothing is printed. This shows that the inner if depends completely on the outer if. Let's improve our little program. Instead of printing nothing when the age is less than 18, let's print out that you must be 18 years old to enter the premises. So now I've just added one more else statement, and inside of which I added a print statement. Now let's run this program and input age less than 18. So now let's run the program, and I'll take something less than 18. Let's take 16 and ID yes. So as you can see that instead of printing nothing, it will actually print out that I must be at least 18. Although nested if statements work, sometimes they can make the code longer than necessary. Remember the logical operators we learned in the previous lesson? And in OR, we can often combine multiple conditions into a single if statement. So instead of writing if the age is greater than 18, and inside of that a nested if statement, that is has ID equal to yes, we can write that if age is greater than equal to 18 and has ID equal to yes. Both the versions will produce the same result. Let's try out the second version, as it is shorter and easier to read. As you can see, I've just quickly went ahead and edited the program, and let's see if the results are the same. So I'll just simply go ahead and input 20 this time. And yes, I have an ID, and there we go. The results are the same. Now let's take a look at another example. Imagine that you're applying for a driver's license. The rules are that you must be 18 and the applicant must pass driving test using the same principles and logic we've just used to write the entry and eligibility program. Go ahead and pause the video to make this program yourself. Now let's build a simple login system. Now, as you can see, I've done the same things as I've done before and taken two variables, that is the user and the password, in which the user will enter their username and the password. I've also predefined and hard-coded the values that we will check against, that is the admin and the password being Python 123. Let's go ahead and give it a try. I'll go ahead and input admin as my username and the Python and the password as Python123. And as you can see, I've successfully logged in. Now let's test the opposite. Now I'll simply go ahead and write 1, 2, 3, 4. And for the let's see, for the password, let's give it hello. And as you can see, my login attempt has failed. Almost every application you use relies on multiple conditions. A banking app checks if your password is correct and whether the two-factor authentication has been completed. An online shopping website checks if an item is in stock and if the payment has been approved. A streaming service checks if you're logged in and whether your subscription is active. These applications make decisions by combining several conditions, just like you've learned today. Let's review what we've just covered. Today you learned what nested conditional statements are, how to place one if statement inside another, when to use nested conditions, how to combine conditions using and or, how to build a simple login system. Your programs can now handle more realistic decision making by checking multiple conditions before taking action. Thank you for watching, and I'll see you in the next lesson.